Okay, people, today we are working on 1-6 day 2 notes, solving absolute value inequalities. So we've done absolute value equations, we've done compound inequalities, and now we're mixing the two and creating absolute value inequalities. First thing we're going to do is we're going to decide whether the inequality is an and, or if it is an or. And the way we do that is with the symbol. If it is less than, think less than, it's a and scenario. So less than, and. That's where you have to stay close. Think of like a leash or think of a leash. I don't know. You got to stay close. You can only go so far away. When you graph it, you'll end up graphing it in one piece. Greater, we're going to misspell greater and think greater. That's where you got to stay back. Okay, that's the 6 feet apart. That is the social distancing. Stay away. When we graph that, we're going to have two pieces. So a less than will look like this. When we put it all together, it'll be a -10 to a 10, and we'll want the chunk in the middle. In this case, not equal to, so open circles, they could be equal to, and it would just be closed circles, but it's still the chunk in between. The greater is the opposite chunks. It'll be the less than -10, or it'll be the greater than 10 piece. And notice that you have two pieces there. If we look at the first example, we have the absolute value of x is less than 3. Less than, so this is an and scenario. So we will have two pieces. We will have x less than 3, and we will have x greater than -3. So it's a double switch. So the first one we just rewrite basically without the absolute value bars. The second one, when we rewrite it, we switch the symbol around and we change the sign. Now when we graph this, here's our -3. I want values that are greater than -3. Here's my +3. I want values that are less than 3. So with an and, remember we want the overlap. So we want the chunk in between 3 and -3, open circles on both because we're not equal to. And then for interval notation, it'll be parentheses, -3 to 3, parentheses, because we are open and not equal to. If we look at number 2, absolute value of x is greater than 5, greater. So this is an or scenario. Again, we'll rewrite the first one, kind of just take away those absolute value bars, or x double switch less than -5. So again, we're going to switch the symbol around and we're going to change the sign on the second one. So here's my 5. I want values that are greater than 5. Here's my -5. I want values that are less than -5. So we'll get the two pieces. Interval notation, -infinity and -5, parentheses on both. Union for that gap in between. Pick it up again at 5 to infinity. Again, parentheses on both because we're not equal to. Let's look at the next one. So here now we have a little more complicated. We have something different in the absolute value besides just x. So this is a less than, so this is an and scenario. And again, we're going to rewrite the first piece just like it is without the absolute value bars. And we're going to rewrite the second piece, change the symbol around, and make it a negative. So we change the symbol and we make it a negative. Notice that the part that's inside the absolute value, that part does not change, just like we had before with the absolute value inequality, absolute value equations, sorry. All right, now what? Now we do it just like normal. Subtract 3 from both sides. We get 2x is less than or equal to 0. Divide by 2, we get x is less than or equal to 0. Solve the other side. Subtract 3 from both sides. we get 2x is greater than or equal to negative 6. Divide both sides by 2. X is greater than or equal to negative 3. So I'm going to graph x is less than or equal to 0. Looks like that. Here's negative 3. X is greater than or equal to negative 3. Looks like that. It's an and, so we need the overlap. So where's the overlap? The overlap is between the two. Close dot because I'm equal. Close dot because I'm equal. Interval notation, since I'm equal, I will have brackets on both the negative 3 and the 0. Again, one piece for the and. Next one, this is a greater, so this will be an or scenario. We're going to rewrite the first one just like it's written, except for we're going to drop the absolute value. Or the second one, we're going to spin the symbol around and we're going to make it a negative 3. Notice what's inside the absolute value does not change. On the second piece, we change the symbol and we make it a negative. Double change. Change the symbol, change the sign. Solve just like normal. Subtract 3 from both sides. We get 2x is greater than or equal to 0. Divide by 2. X is greater than or equal to 0. On the other piece, subtract 3 from both sides. 2x less than or equal to negative 6. Divide both sides by 2. X is less than or equal to negative 3. So, greater than 0. Here's my x is greater than 0. Here's my negative 3. Here's my x is less than or equal to negative 3. So my final graph, since it's an or, and I only need one piece to work, will look like that, the two pieces. If you take a look at number 3 and number 4, they're the same problem. One's less than and one's greater than, so you can see what the difference is. One, you're graphing the pieces that are kind of away, and one, you're graphing the pieces that are close by. Interval notation, parentheses always for infinities and negative infinities. This was equal to, so we'll put a bracket on the negative 3. Union for the gap, whoa, not a parenthesis. Hold up. Need a bracket. 0, comma, infinity, always parentheses with infinities. Looks like that. Number 5. First thing you notice about number 5 that's different is that the absolute value is not by itself. So just like with equations, we have to get the absolute value by itself first. Same thing with inequalities. So we're going to subtract 5 from both sides. That gives us the absolute value of 4x minus 7 is greater than 5. Now we can decide and or. This is greater. So this is an or scenario. Rewrite the problem. First piece is the same without the absolute value. Or second one, double switch, less than, and a negative 5. Remember, the part that's inside the absolute value does not change. The double switch happens with the symbol and with the sign on the second piece. Solve the inequality just like normal. Add 7 to both sides. Divide both sides by 4. We get x is greater than 3. On the other side, we're going to add 7 to both sides. That gives us 4x is less than 2. Divide both sides by 4. We get x is less than 1/2. So here's 3. I want values that are greater than 3. Here's 1/2. I want values that are less than 1/2. So we'll have an open circle going to the left, open circle going to the right. Interval notation, let me shrink this a little bit. Negative infinity to 1/2, parenthesis, union, parenthesis, 3 to infinity with another parenthesis. Nothing was equal to, so we need parentheses on everything. Let's take a look at number 6. So number 6, the absolute value is not by itself either. So we need to get the absolute value by itself. This is why you wait until you have the absolute value before you make a decision about and or. Right now we're saying, hey, this is a less than, so it must be an and, right? But what happened? We're going to divide both sides by negative 3. We get the absolute value of 3x plus 1. When we divide by a negative 3, what do we have to do? We have to flip our symbol around. So now this is really the absolute value of 3x plus 1 is greater than or equal to 3. Greater. So this whole idea of, hey, this is a less than, it's an and, is wrong because now it's really a greater than, which makes it an or scenario. Then what? Oh, then we rewrite the first one without the absolute value bars, or rewrite the second one, double switch, switch the symbol, switch the sign. Solve each like normal, subtract 1 from both sides, divide both sides by 3, x is greater than or equal to 2/3, subtract 1 from both sides, divide both sides by 3, x is less than or equal to -4/3. So here's 2/3, I want x is greater than or equal to. Here's -4/3, I want x is less than or equal to. So the or will be exactly like the sort of intermediate graph or scratch graph maybe. Interval notation, -infinity to -4/3, bracket because we're equal to, union, pick it up again, 2/3 to infinity, bracket on the 2/3. Number 7, we got a lot to get rid of on number 7. First thing we want to do is get rid of the 2. So we're going to subtract 2 from both sides. That gives us the absolute value of 2x plus 8 divided by 5 is less than 3. Then we're going to multiply both sides by 5. Now we have the absolute value of 2x plus 8 is less than 15. Now we're ready to decide, is this an and or is this an or? This is less than, so this is an and scenario. So think your graph should be in one piece when it's done. Rewrite each piece. First one, just drop the absolute value, whoops, not equal to, just strictly less than. And then we've got a 2x plus 8 double switch greater than -15. Subtract 8, divide by 2. We get x is less than 7/2. Subtract 8, divide by 2. We get x is greater than -23/2. So here's my 7/2 less than. Here's my -23/2 greater than. It's an and, so I want the chunk in between. Open circles on both. So for the interval notation, both pieces get parentheses. Last but not least, number 8. First thing we're going to do is we're going to subtract 1 from both sides. That gives us -8. Absolute value 3y minus 6 is less than or equal to 8. Then what? Then we're going to divide both sides by -8. So the absolute value of 3y minus 6. Now we are greater than or equal to -1. Greater or scenario. Remember, you have to flip your symbol around when you multiply or divide by a negative. So then what? So then we're going to take the first piece, get rid of the absolute value bars. Second piece, double switch, switch the symbol, switch the sign. And this is an or. Add 6. Divide by 3. Ran out of room. Greater than or equal to 5/3. Add 6. Divide by 3. And if you're inside the absolute value was a negative coefficient, then you could have to switch your symbol around again. So what I have now, I have 5/3. I want y is greater than or equal to 5/3. Here's 7/3. I want y is less than or equal to 7/3. This was an or, so I only need one piece to work. So one piece works here. Both pieces work here, so that counts for an or. And one piece works here. So what do we end up with? We end up with the entire number line. Interval notation for that, -infinity to infinity. Now, the reason we end up with the entire number line is if we go back to here, think about this for a second. The absolute value has to be greater than or equal to -1. What do we know about absolute value? We know that absolute value is always positive. So that means this value here is going to be a positive. is a positive number greater than or equal to -1?